So y equals ax squared plus bx plus c. So in standard form, there's no parentheses. The other difference is you have an x squared term and you have an x term. So you should be able to identify when something is in standard form and when something is in vertex form. So you don't have to write this part, but yesterday we looked at vertex form. So vertex form, A has the same job in both cases. It's the stretch value and the concavity up or down. And then here's x squared. The h told us left or right. See how there's no h value telling us left or right? And then this k value told us up or down. There's no k value. So I could not determine the vertex when it's in standard form just by looking at it. So the different parts, A is your steepness again, and your concavity. So it has the same job. That's why they gave it the same name, A. And then B is how you're going to actually find your vertex. So negative B divided by 2A is our axis of symmetry. So we are going to use that formula, the opposite of B divided by 2A, every time that we're in standard form. So that's the only piece that needs to really get memorized for your test next week. And then after that test, you could always go back and look it up in your resource section. But negative B over 2A, we're going to use like 20 times. So it should be, start to sink in. And then the C value is actually your y-intercept, because if you plug in 0 for x, this goes away, and you're just left with that constant. So it actually will tell you the y-intercept of your graph. So we're going to use these 3 steps to graph quadratics, and you still have to know that parent function. So what were the key points for that parent function? The vertex, if it starts at 0, 0, what are the other 3 key points that we are trying to remember? 1, 1, 2, 4, and 3, 9, because 1 squared is 1, 2 squared is 4, and 3 squared is 9. So once we find the vertex, everything else is the same as what we did last time. So here's your first standard form equation. The first thing I like to do is identify A, B, and C. So in this problem, there's nothing written in front of x squared, so A is just 1. B is negative 6, and C is positive 4. Will this be concave up like a smiley face or concave down? And how do you know? It is concave up. How did you know? Right, there's no negative. A is 1. So it's going to be concave up. So I already know the direction of my parabola. What about my stretch? Will it be steeper, less steep? Will it be the same as the parent graph? How do you know? Why? Yeah. Right, so A is 1. So it's the same as the parent graph. 1, 1, 2, 4, 3, 9. So you already know what the general shape is going to look like. So now we need to find the equation of that axis of symmetry or line of symmetry. So I do negative B divided by 2A. So in this problem, if B is already negative 6, what will be the opposite of B? It'll be positive 6, because a double negative, right? Negative, negative 6 will give you positive 6. And then I'm dividing that by 2 times 1, because A was 1. So what's 6 divided by 2? 3. So my axis of symmetry is at x equals 3. So I know the x value of my vertex. If you know the x value in a function, how do you figure out the y value of the function? What? I can't quite hear you, but you're going to plug the x value in to the function. Is that what you said? Yep. Well, the y-intercept is going to be our last step in a minute, but let's finish this coordinate of the vertex. So if I have 3 for x, I'm going to plug in and do 3 squared minus 6 times 3 plus 4 to generate the output of the function. 3 comma what? So this would be 9. 3 squared is 9. I'm subtracting 18 because 6 times 3 is 18 and adding 4. So what do I get as the y value of my vertex? Negative 9 plus 4 would be negative 5. So my vertex is at 3 comma negative 5. So I can finally plot something on my graph. So 3 comma negative 5, and it's going to be the parent function from there. And Wes was reminding me that I can find the coordinate of my y-intercept. How? The rule was that C is the y-intercept, because when I plug in 0, I get 0, 0, and I get 4 left over. So 0 comma 4. I like finding the y-intercept because it's a good check for yourself when you're graphing your parabola that you're graphing it in the right direction with the correct steepness, that you've got the right vertex. So from my vertex, if I go over 1 and up 1, and then go from the vertex over 2 and up 4, do you see how the y-intercept is over 3 and up 9? So it should fit the pattern as I'm graphing. If it doesn't fit the pattern, you did something wrong. You plotted the y-intercept wrong, the vertex wrong. If that's the parent graph, just like yesterday, just we're finding the vertex a different way. So you should be really good at graphing parabolas after this. Any questions on that example? So I'm going to do a couple more with you and then see if you can follow those steps to graph some on your own. And if you notice, now I'm going to start changing that A value to do different things. I think of this as the ABCs. So, what does A tell you? What does B tell you? And what does C tell you? The ABCs of standard form. Oh, the other thing is you always have to have it in standard form. So if for some reason I wrote my equation like negative 5 plus 4x minus x squared, it doesn't matter that it's written in that order. This is still A, this is still B, and this is still C, right? A is always in front of x squared, B is always in front of x, and C is always the constant. So in this problem, A would be negative 1, B is positive 4, and C is negative 5. I think if you write those out for yourself, you're less likely to make mistakes. So tell me something. What does A tell you about this function? It tells you two things. Concave down. What else does it tell you? What's the steepness? It's going to be the parent graph, right? Same slope or same steepness of the curve. All right, my B information, I do negative B over 2A to find that axis of symmetry. So I just think of this as the ABCs. I do my ABCs and then I can graph it. All right, this time B is positive, so I make it negative 4, and I'm dividing by 2 times negative 1. So what is negative 4 divided by negative 2? Positive 2. All right, so my vertex is going to be at 2 comma something. So I need to plug 2 into the original function to solve for y. So it would be negative 2 squared plus 4 times 2 minus 5. See if you can get the right y value. And remember that if it's a negative 2 squared, it's going to stay negative because the negative 2 is not in parentheses. So keep it a negative 2 squared. What would you get as the y value? Is that what it comes out to? Yeah, because this is negative 4 plus 8 minus 5 is negative 1. Good. So my vertex is at 2, -1. So I can finally plot that 2, -1 on my graph. And what's the last piece that I should check? If I do the ABCs, what does the C value tell you? The y-intercept should be at 0, -5 if this is all going correctly. So maybe that would help remind you that, oh yeah, this is concave down. It is the parent steepness. So I would go over 1, down 1. Over 2, down 4 should hit that y-intercept exactly. And then over 1, 2, 3, down 9, I would be at -10. So that's a concave down one. You find the vertex and then you do the moves in that direction. All right, one more together. And so this is a little bit more labor intensive, isn't it? On vertex form, I literally could plot the vertex and just go. This takes a little bit more work when it's in standard form. Can I go down to the last one? All right, so I'm going to identify my A value is 2, B value is -8, and C value is 6. What does A tell me this time? Tells me two things. It's going up, concave up, and what else is it telling me? What does the 2 do to the Y values? Yep, it's going to be steeper times 2. All right, now I'm going to do -B over 2A to find my vertex. B is -8, so -B is going to be +8 this time. And I'm dividing by 2 times 2. So 8 divided by 4 is 2. So now you're going to plug 2 back into the original function and see what you get for your Y value. So someone tell me what they get for the Y value. Let's see if we get the same answer. 8 minus 16. Yep, that sounds right to me. 8 minus 16 would be -8, plus 6 would be -2. Is that what anyone else got? Check our answer to make sure that we're on the right track with our vertex. I think this is right. 8 minus 16 is -8, plus 6 would be -2. Did you make sure that you didn't do 4 squared and get 16 right here? Because you only square the first 2. You don't do 2 times 2 first. So you do 2 squared is 4 times 2. All right, so then my y-intercept is at +6. So I should be way up here. And the axis of symmetry might help you with your graphing because then you know that it's symmetrical over that axis of symmetry. So I know that if this is the y-intercept, this point is right here. And that is over 2 up 8, right? Because usually I go over 2 and up 4. So this is twice as steep. So the only other point I need is over 1 and up 2. It's twice as steep as the original. Usually it's over 1 and up 1. So that one is twice as steep. You only change the Y values. So I'd like you to try, there's 4 examples. I don't know if you'll get through all 4. I'd like you to try to, and then I do not think we're going to have time to practice converting. We'll do the converting tomorrow when we do some practice. So I'd like you to try the guided practice. Maybe in a few minutes I'll put up the answer to number 1 so that you can kind of check as you go.